This section will cover exponential functions. Let's get started. What is an exponential function? An exponential function is a function of the form y equals a times b raised to the x, where a is not equal to 0, b is greater than 0, b is not equal to 1, and x is a real number. Linear functions have a constant rate of change, while an exponential function has a constant finite ratio. Identifying linear and exponential functions. Let's look at an example. Does the table represent a linear or exponential function? Well, let's see. We can see that from our table, our x values have a difference of 1 between the values. So with the first value of x being 0, with the 1 being added to it, that makes the second value 1, and if you add another 1, that makes the third value 2, and if you add another 1, the fourth value will be 3. Let's look at our y. Well, if we multiply the negative 1 by 3, we get our second y value. And it appears if we multiply negative 3 times 3, we get our third y value, which is negative 9. And what do you know? If we multiply the negative 9 by 3, we get our fourth value, which is negative 27. Therefore, the ratio between each y value is 3. The table represents an exponential function. Since there is a common difference of 1 between the x values and a common ratio of 3 between the y values. Let's look at another example. Does the table represent a linear or exponential function? As we saw before on a previous slide, x here is also increasing by 1. The difference between each x value is therefore 1. Now let's look at the y value. We can see that the first y value is negative 1. Well, if we add 2 to it, it gives us our second y value, which is positive 1. And then if we add another 2 to the second value, we get 3 for our third y value. And then if we add another 2 to the third value of y, we get 5. Therefore, the common difference between y values is 2. The table represents a linear function instead of an exponential function. And that is because there is a common difference of 1 between the x values and a common difference of 2 between the y values. Remember that in order for it to be an exponential function, it must have a common ratio in the y values. Okay, here we go again. Does this table represent a linear or exponential function? Well, once again, we see that the x value is increasing by 1. So the difference between each x value is 1. Now let's look at the y value. Our first y value is 2, and our second is 8. Well, 2 divided by 8 is 4. So let's see if each y value has a common ratio of 4. We know that if we multiply 2 times 4, we get 8, which is our second y value. Now, if we multiply 4 by 8, we get 32. So therefore, that's our third y value. Now, if we multiply by 4 again, we get 128 for our fourth y value. Therefore, we have a common ratio between each y value as a number 4. The table represents an exponential function. Since there is a common difference of 1 between the x value and a common ratio of the difference between the y values as 4. Now you try. Does the table represent a linear or an exponential function? What is the common difference in the x values? What is the common difference or ratio in the y values? And in your conclusion, what does the table represent? Take a couple of seconds and determine what your solution will be. Let's check your solution. Does the table represent a linear or exponential function? X is still increasing by 1 in this case, and the difference between the x values is 1. Let's look at the y values. Well, if you add 3 to 6, you get 9, which is the second y value. And if you add 3 to 9, you get 12, which is the third y value. And adding another 3 will give you the fourth y value, which is 15. So therefore, there is a common difference between the y values, which is 3. Then the table represents a linear function, since there is a common difference of 1 between the x values and a common difference of 3 between the y values. Remember, in order for it to be an exponential function, there must be a ratio in the y values. And in this case, we do not.